Simulation result number 4. The irregularities in actual 3 result topology. In actual result analysis number 4. Irregularities in 3 result topology. In actual deployment of 3 result topology in practice, irregularities may exist due to satellite position deviation, node failures, ISL interruption, etc. First, we consider the random satellite position deviation and node failures. We add a random deviation to the nominal phase of each satellite to simulate the actual satellite distribution, where del U is approximately n of 0, sigma square, where sigma is equal to 1 degree. Also, a specific proportion of satellites are randomly disabled as well as their ISLs. Figure 17 compares the effect of the irregular topology on the average hop count. We can find that the average hop count increases with the disabled satellite nodes compared to the regular 3ASL topology. In all scenarios with the 10% disabled satellites, the average hop count increased by around 0.5 hops, but the relative deviation is relatively small, ranging from 2.08% to 8.77%. The resulting table 1 are based on the regular topology. Resulting figure 17 illustrates the actual irregular LEO constellation scenarios. The result will be affected depending on the number of missing node or links, but the impact is relatively small and the conclusion is still applicable overall. As satellites in adjacent orbits passes before the and after the orbital intersection point, the interplane ISL experiences a dramatic change in orientation. If the ATP supports tracking link point ranges, the ISL can be maintained at all times. However, the ATP fails to support the interplane ISL pointing range. The ISL needs to be interrupted and then re-established after passing through the orbital intersection. At this point, we consider two scenarios. Operational ISL model. The satellite carries 4 ISL terminals but only activates 3 to save resources. In this way, by dynamically and operationally rebuilding the link, the 3 ISL topology can be maintained. Number 2. Constructive ISL mode. These satellites are launched with only 3 terminals. At this time, before and after each satellite pair passes through the orbital intersection, the interplane ISL connection status will switch, causing the irregularity in the ISL topology near the orbital intersection points. However, outside of this area, a regular 3 ISL topology can still be maintained. Conclusion. The article for the first time investigates the topological and routing properties of pruned 3 ISL topology in LEO constellation network, that is the 3 ISL topology. Key routing properties are formulated and derived. The main feature is that the pruned interplane ISL causes inevitable jitters when the required interplane hops are more than the intraplane hops. When the required intraplane hops are more than intraplane hops, the pruned ISL causes inevitable jitters. The numerical simulations verify the properties and indicate the pruned ISLs may degrade the network performance, especially hop count. However, these impacts can be mitigated in real satellite network scenarios. A dedicated constellation configuration that distributes the satellite more densely in each orbit rather than across the more planes can lessen the impact. The theoretical framework and result can be analyzed to impact the different ISL configurations on LEO constellations and guide the co-design of constellation pattern and ISL topology. More specifically, they can explain and analyze the advantages and disadvantages of 3 ISL topology compared to the typical 4 ISL configuration. Thank you.